All right, this is going to be a video just to show you how to do your homework. Counting significant figures. I'll probably just do the odd numbered ones, and that way you'll have the ability to do the even number ones. So the first thing we're going to do is we're going to be using the Atlantic Pacific rule. So if the decimal is present, we're going to find the first zero number on the left, then count all digits to the right. If the decimal is absent, find the first non-zero digit on the right and count all of them to the left. So rule number 2 is every digit in scientific notation is significant, except for the times x to the whatever exponent is. Any number that's counted is an exact number that will have an unlimited number of significant figures. So if we're counting numbers, it's going to be unlimited. These we're all going to assume that we've got, these are all numbers that are measurements. So let me zoom in here, and again, we're going to do the odd numbered ones, and I'll talk you right through it. So number 1, we want to know how many significant figures. Well, there's no decimal place, so the decimal is absent. So we're going to come from this direction, and we're going to go to the first non-zero number, which is 4. Once we start counting, we're going to count till we run out. So 1, 2, 3, 4, 5. This will have 5 significant figures. Let's jump down to number 3. Number 3, decimal is absent, so I'm going to come from this direction, from the Atlantic Ocean. And in my first non-zero number is a 9. Then I'm going to count till I run out. So this is going to have 2 significant figures. Number 5, decimal is present, so I'm going to start from the Pacific side of the number. And my first non-zero number is 9. And I just count until I run out. So that's going to be 1, 2, 3, 4, 5, 6. This next number, number 7, decimal is present. So I'm going to start from the Pacific, and I'm going to go to my first non-zero number, which is the 1. I count until I run out, so this will have 3 significant figures. Number 9. Number 9 is scientific notation. So in scientific notation, we're always going to ignore this part of the number, and these are always significant. You could also follow the Atlantic Pacific. Basically, this has got 2 significant figures if we were coming from the other side, but basically in scientific notation, you can just look at the number, ignore the times 10 to the exponent, and that'll give you significant figures. So this will have 2. Jumping down to number 11, decimal's present, so I'm going to go from the Pacific side, or from left to right. 3 is my first non-zero number, and I count until I run out. 3 significant figures. For 13, notice that there is a decimal here. So decimal is present, so I'm going to start from this side. 7 is my first non-zero number, and I count till I run out. 15, decimal is present, start from this side. First non-zero number, 1, 2, 3, 4, 5, 6. 17, decimal is present, so I'm going to go from this side. 3 is my first non-zero number. I count until I run out. This will have 3. Number 19 is scientific notation. So again, I'm going to ignore this and count how many numbers there are, and there are 4. All right, let's do a little bit of addition and subtraction problems. And I'm going to grab a calculator here. Now, the rule for multiplication division is we're going to be counting significant figures. The rule for addition and subtraction is the least number of decimal places, or the lowest value. So let's take a look at these 2 numbers. So for these 2 numbers, when I add them together in the calculator, we've got 8.20 plus 20. So the number I get in the calculator is, I'm going to write this down, 28.2 is what I get in the calculator. But I'm going to look to see which number I have that's significant. So when I'm putting these in the calculator, the least number of decimal places, or the least accurate number, is going to be, this one has no decimal places. So I can't have a 0.2. So my answer is going to be 28. I'm going to round that so that it's to a whole number, because this one here was to a whole number. Let's do number 5. We got a subtraction problem. 39.3 minus 0.804. Well, this is my lowest number of decimal places, so I have to round my answer to 1 decimal place, or the tenths place. The number I get in my calculator is 38.496. I have to round to this place. The 4 is followed by a 9, so that's going to change that to a 5. So my answer is going to be 38.5. Let's do number 3. Addition problem. 42.828 plus 67.4629. The answer I get is 110.2 909. Now I'm going to look for this is the least number of decimal places is in the third decimal place spot, which would be right here. The 0 is followed by a 9, so it's going to round up. So my answer is going to be 110.291. Now, that's the rules for addition and subtraction. We always look at the lowest number of decimal places. Now, for multiplication and division, we're doing the least number of significant figures. So let's put these in the calculator, and again, I'll do number 1. 7.6 times 21.9. Put that in the calculator, and the answer I got, I'm going to write that right down here, is 166.44. Now I'm going to count the number of significant figures because I need the least number. This number has 2 decimals absent, so 1, 2. This number, decimals present, 1, 2, 3, 4, 5, 6. This has 6. So I need to round this answer to 2 significant figures. So decimal is present. So here's my first number. Here's my second number, followed by a 6. So that's going to cause the other 6 to round up. So rounding this, it's going to be 170. Okay? This one caused that to round up, and this is a 0. So now it has 2 significant figures. Whoops, and I just did the wrong problem. You wrote it in the wrong spot. Back up. I had the number written underneath it. So right here was 166.44. We've got 2 significant figures we need in our answer. This has 3. So I do need this rounded to 2 significant figures. So that's going to be 170. That's what happens when you write the number in the wrong spot. Let's do number 3. We'll go over here. We've got multiplication. So 5.00009 times 0.06. So when I put that in the calculator, I'm getting 0.3000054. This number here has 1 significant figure. This number here has a lot more than 1 significant figure. It's got 1, 2, 3, 4, 5, 6. So I need to round this to 1 significant figure. So coming from this direction, decimals present, I'm looking at this one. It's followed by a 0, so the answer is going to be 0.3, or 0.3. Let's do number 5. It's division. Put it in my calculator, 500,009 divided by 17.000. And there's my answer. I'm going to get a very long answer. It's 29412.2941176, blah, 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 blah. Let me look and see how many significant figures I need. So decimals absent on this one. So I'm going to start from this direction. 1, 2, 3, 4, 5, 6. Decimals present. So I'm going to start from this direction. 1, 2, 3, 4, 5. So I'm going to need 5 significant figures in my answer, because it's the lowest number of significant figures. So I'm going to be looking here, decimals present, 1, 2, 3, 4, 5, followed by 0.2. So it's going to stay the same. So when I round this one, the answer is going to be 29412, and that would be my final answer. All right, the ones on the bottom here, same sort of thing, just a mixture of problems, so you go ahead and try those on your own. I hope this video helps, and we'll see you later.